Flipped classroom video for Maths A2 Unit 3, Combining Graph Transformations. So, combined transformations. First of all, a reminder. If we have a function y equals f of x, there are four basic transformations. We can have y equals a f of x, which is a stretch away from y equals 0 with a scale factor of a. SF means scale factor, of course. And that looks like that. The blue one has been stretched by a factor of 2 away from the y equals 0 or x-axis. Y equals f of x plus a, and that is a translation of y in the y direction of a units. So we can see that the red curve is the same as the green curve, moved up by 2 units. We can have y equals f of ax, and that's a stretch from x equals 0, but with the scale factor of 1 over a. So this is the one that sort of does the opposite of what you might think. And you can see that the green curve has been squeezed in by a factor of 2, or stretched by a factor of a half into the purple one. And then we have y equals f of x plus a, which again translates in the x direction by minus a units. So again, possibly counterintuitive when you first come across it. And so we can see there that the yellow curve has been moved minus 2 units. So that would be, if the green one is f of x, which it is, that's f of x plus 2, and it has moved it in the negative direction. Okay, so transformations in the opposite directions. If we carry out transformations in opposite directions, and what I mean by that is one in the x direction and one in the y direction, then the order doesn't matter. Okay, so let's consider a stretch of scale factor 2 in the x direction and a translation of 3 in the y direction. So the first one, if we want to stretch the scale factor 2, then we have to do f of x divided by 2, because of that sort of opposite to what we might have thought business. And the second one takes f of x to f of x plus 3. So that means if we do it in that order, then we have f of x going to f of x over 2, and that then goes to f of x over 2 plus 3. And that looks like that. The green one is where we started. We then stretch it away from the x equals 0 line, and then we translate it up by 3. Now, if we do it the other way round, then f of x goes to f of x plus 3, and then it goes to f of x over 2 plus 3. So, if we look at it graphically, what's happened is the green original curve is moved up by 3 by the first transformation, and then is stretched out by a scale factor 2 away from the x equals 0 line. And so the end result is exactly the same. Okay. However, transformations in the same direction are a bit more tricky. So if we consider a stretch of scale factor 2 in the x direction and a translation of 3 as well in the x direction, then what happens? Okay, the first takes f of x to f of x over 2, as we saw before, and the second takes f of x to f of x minus 3. And so that means we either have f of x going to f of x over 2 and then going to f of x minus 3 over 2, and that looks like this. The green curve is stretched by a factor of 2 away from the x equals 0 line, and then is shunted along by 3 in the positive x direction, because that's the way we're translating. Of course, as a transformation, it's written as f of x minus 3. The other way round is we translate it first by 3 in the positive x direction, hence f of x minus 3, and then we apply the stretch, so that gives us f of x over 2 take away 3, and you can see those functions at the end don't look the same, and we can see what happens. So as transformations, if we think of them in that way rather than in a function way first, then of course if we move it along by 3 first, so that minimum is going from an x value of 4 to an x value of 7, if we then stretch it, that x value of 7 is going to become 14. So we're getting an extra, it's stretching further because it's moved further away from the x equals 0 line. And in terms of the functions, we can see that it's different as well. And so we have to be very careful in these cases. For the second one, if we wanted it to match, how could we make it the same as the first one? Any thought? Have a think about that. I'll give it a little pause for you to think. Well, and now I'll answer it. So if you could have paused it, of course, with a pause button. But if you think of the blue function on the top line, at the top of the two coloured lines there, it's f of x minus 3 divided by 2. That means we have f of x over 2 take away 3 over 2. So if the yellow 3 on the line below was actually 3 over 2, that would be the same. So that would mean if we change the purple one, so that instead of a translation of 3 units we just did 3 over 2, or 1.5 units, then that minimum would have been shunted across to 5.5, and then when we stretched, 5.5 would have become 11, and that would indeed have matched the graph on the top picture where the minimum is at x equals 11. So think about that. That will actually, I hope, make things make a little more sense for you. Drawing combined transformations. So, transforming a graph. We might want to transform a graph whose function we don't know. So, here's a function, and we might want to know what does y equals a half f of 3x look like for that curve. And so we'll just run through the steps you might take in order to do that. So we've got two transformations. We've got a stretch of scale factor a half in the y direction. The half is outside the function, so it's in the y direction. And that means that for the points A and B, or for the point A anyway, we can mark 0 minus a half, because that's halfway between A and the y equals 0 line, or the x-axis. The B will stay where it is, of course. We've also got a scale factor of a third in the x direction. So that means the point B would be moved to the point 2, 0. So we can mark that on. Now for the minimum, they haven't given us any coordinates for that, but what we can do is we can make sure we squeeze it both ways anyway. So first of all, if we look at the x coordinate there, and then, oh, actually we're looking at the y first, so that's just giving us an idea of how far down it is. So that's the y coordinate, and then we draw a dotted line across, meant to be horizontal. It looks a bit dodgy from here now. Look at it on a bigger screen, but never mind. It's roughly halfway, which is what the stretch of scale factor half in the y direction tells us. And then for going the other way, we're putting a line across, a horizontal line, which will then roughly mark into thirds, and then it's the one that's 1/3 of the way along, because we had a scale factor of a third in the x direction. So roughly the minimum will move to there, where I've just put another red blob, and we can now join those points up as best we can. So we put a curve through there. Doesn't look great, I realise, but it's pretty close to what we should have. Let's see what it would look like. Well, there it is, exactly marked on, and that's not too bad.